Okay, engineers. So after we did the sorting of playing cards into black cards and then also getting out the black ones that are less than 5, we ended up with this really efficient code. I took out the shorter one, but I neglected something. I intentionally overlooked the fact that we were using a variable that we never actually declared, and we never told the computer exactly how many times to go through this loop. So if you look at this code, can you figure out where the variable is that we need to work on? Well, hopefully you did notice, and it is this one, number cards. So I'm going to edit this code in Robot C just so you can see the process a little bit. But here's the exact same code. We had task main. While number of cards is greater than or equal to 1, we're going to go through sorting the black ones less than 5 or everything else. So in order to declare this variable, it's not okay to just start using a variable. The computer has no idea what you're talking about, which is why it's not any kind of color. I'm going to go ahead and put some spaces in front of my while loop. So under task main is where you can make a local variable. This is a variable that's going to be used in this function of task main. And because number cards is always going to be a whole number, it's not going to be a decimal, it's not going to be negative, and it's a number between 0 and 52 because I have 52 cards in my deck. I'm going to start by saying int for integer, so the computer knows I'm always expecting an integer here, and number of cards is the name of it. All right, so that is my declaration. I'm going to say declare number cards. All right, now I need some value for number cards because if I went from here into the while loop, number cards doesn't have a number attached to it, and this cannot be evaluated. We can't tell if it's greater than or equal to 1 if it's just if it's an empty variable. So if I think about my deck of cards that I'm starting with, I want my loop to only go through as many times as needed for that deck of cards. So if I wanted this loop to repeat forever and ever and ever, you know, we've done this before where we say while 1 equals 1, and because of that always being true, this could just go forever and ever. That would work. However, we don't want to do that because we do want the robot to be able to stop itself instead of you having to step in and pressing stop on the debugger window. So I'm going to start by saying number of cards is going to be the full deck, which in this case is 52 cards. And I need a semicolon at the end of that. And now this is going to work. Now keep in mind that you can also do this in one line. You don't have to do it in 2 separate lines and kind of merge it. So I could just put equals 52 up here and then not have this whole line. And that makes it a little nicer to read. So I'm going to say declare and initialize number cards. All right, now if we go into the loop, the computer is going to read 52. Is it greater than or equal to 1? Yes, that is true. So then it's going to go ahead and sort a card. Now, at the end of the if and the else, depending on which branch it went into, our computer is going to be right here. I'm going to put some spaces down here. So right in this area, and once it reaches the end curly brace, it's going to think, okay, well now I need to go back and check the condition of my while loop because I'm looping. However, it's going to say number cards is still 52, and it's going to be yes, greater than or equal to 1, so it's going to sort another card. Back down to this curly brace, go back up, 52 greater than, it could just keep doing that forever. And that's another way you could get an unending loop. However, that's not the point. We said we wanted it to end the robot to stop by itself. So that means before we go back up to the loop, before this curly brace, then I need to put some condition that says number of cards is decreasing, because if you look at our deck of cards that we're sorting through, it should be getting shorter. So again, thinking like a computer, when I'm reading through this while loop, I'm going to either put a card into the left pile or I'm going to put a card in the right pile. I'm not going to do both because if I go through this branch, then I skip down to this end curly brace. Or if I do this one, I'm going to skip. I've already skipped this if part, and I'm going to be down here. So both these branches come back together to do, or I can put in here one more step before it loops. So I'm going to reassign number cards to reflect decreasing deck of cards left. All right, so I like to put the comment sometimes first, just so I know what I'm doing. And my command here then is going to be to reassign. So when you assign a variable, just like when we initialized it, you write the variable name, you put an equal sign, and this means the new value for number cards is going to be equal to the current value of number cards. I know this is confusing because they look exactly the same, but the one on the right side is always going to be the current value of number cards, and the one on the left is basically when you're done with this line, that will be the new assignment. So I want to take the current value and subtract 1. And I need a semicolon to complete that thought. And that means now number cards after one time through this is going to be equal to 51. So once I get to this end curly brace, the computer comes back up here and says, well, 51, is it greater than or equal to 1? Yes, it is. And it's going to go through and make sure that card gets sorted. Then the new value, new value of number cards is going to be 51 minus 1, which is 50. So you can see it's going to continue to decrease by 1. So finally, let's say we're on our last card. So once we've sorted the last card, our number card would have, our current value of number card would be 1. So when you do 1 minus 1, our new value of number cards is 0. So once you go back up here and the computer checks is 0 greater than or equal to 1, that is not true, then it's going to skip this entire everything inside the curly braces for the while loop, and it's going to get to the end of the program, and it knows it's done. So that is why variables are very useful. There is also a second way that we can use variables in this case without decreasing the number every time, and that could be counting up. So for example, if we wanted to start with the number of cards that have been sorted, maybe I'm going to change this into sorted cards. I would want to start by saying I'm not going to have any sorted cards at the very beginning. And then I have to change my comment as well. This is always something you should make sure you do if you modify code. And then while sorted cards, cards. All right. We want to say while the sorted cards is not all of the deck yet, so maybe I can say less than the full deck, which is 52. So while the sorted cards is less than 52, I still have work to do. And at the end, the difference, besides changing all the names of these, is that the number of sorted cards should be increasing at every step. And that way I would have +1. And I need to change my comment. Reassign sorted cards to reflect number of cards sorted. So you can do the opposite basically here. Instead of having the number of cards decrease, you can add them and count all the way up to 52. And so you can see that it's important to have that declared and initialized variable that also gets changed every time the loop gets has gone through one time. Otherwise, you're not actually effectively using the loops. One more option, and this might be true with cards and maybe not with a lot of other things, is you could actually just count until you've gotten the 8 cards you need that are the black ones that are less than 5. So for example, I would maybe rename this variable so it's also, actually we could use sorted cards because we want the 8 ace through 4s that are black. Let's say we start with none of them and we want to make sure we get all 8 of them. So until we have something great or less than or equal to, I'm sorry, no, we want 8, so we want to do this until we have, no, that's not right. We don't want to only do the loop while we have 8. I have to think this one out. We want to actually keep doing this loop until we have 8. So I'm going to say while our sorted cards is still less than 9. Is that right? I think so. No, that's 8. Sorry. Okay. So while sorted cards is less than 8, that means we still have not gotten the 8th one. We could have up to 7, and then the loop should keep going. And what I'm going to do here is say that I'm only counting the cards that are black and that are less than 5. So after putting something in the left pile, this is where I want to increment my variable, okay? So add 1 to sorted cards. That means if I end up getting a red card, right? Let's say I haven't gotten to my 8 yet. If I get a red card, it's going to skip all this. It's not going to increment or add to the sorted cards variable. It's going to put that in the right pile, and it's going to come back here and still think, oh, I haven't gotten all of my 8 yet. So in order to write that, I could write sorted cards is equal to the current value of sorted cards plus 1. So notice that this is useful if you don't want the increment to get bigger every time, either if you got a red or a black card, or if you got a black card greater than 5. You want it only to get incremented if this condition is true. And so that might be nice, because then you don't have to sort through all 52 cards if for some reason all 8 of the ones you want were near the top. And that is even more efficient, because that way your program ends sooner and you save some energy.